Okay, let's jump right in. If your browser automation runs perfectly with just one profile, but completely falls apart when you try to scale it up, well, the issue probably isn't your script. It's almost certainly your profile strategy. You see, when a team kicks things off with just a single browser session, everything feels incredibly simple, right? You run a test, submit a form, maybe validate a client-approved workflow, or support a QA task. And boom, that one profile works absolutely fine.
But then the workflow grows. You add more profiles to the mix, suddenly you've got multiple sessions forced to run in parallel and a lot more people depending on that output. In almost overnight, a process that used to take seconds, it crawls. It gets incredibly unreliable and it turns into a total nightmare to debug. You start getting these random timeouts and blocks that literally never happened when you were just running that single isolated instance.
Section 1. The scaling illusion. Why browser state matters.
So this brings us to a really critical realization. Browser profile isolation absolutely has to evolve from being just this minor setup detail into a full-blown operation strategy. And to understand why, we need to look at what a browser profile actually carries. Remember, it's not just an empty window. A profile holds all your cookies, your storage, your entire session history, plus very unique device signals, distinct fingerprint characteristics, and its own runtime behavior. If your workflow relies on handling CAPTCHAs, running complex automations, or passing third-party verification, these specific little details are exactly what dictate whether you succeed, fail, or just get stuck in an endless loop of CAPTCHAs.
And this contrast really hits the nail on the head regarding why state matters so much. Think about a regular Chrome setup. It defaults to sharing cookies. It exposes your real IP through WebRTC leaks, keeps a consistent canvas hash. And because of all that, it carries a super high detection risk. But a stealth-configured browser, that changes the game entirely. With that, you're getting unique fingerprints per session, masked WebRTC, strictly isolated cookies, and randomized hashes. It's a night and day difference that highlights why you absolutely need true isolation to prevent state leakage between your automated tasks.
Section 2. The operational checklist. Moving from setup to strategy. All right, to actually manage this like a true operational system, rather than just running a casual script, Step 1 is to identify the business workflow. You really have to ask yourself, what specific process depends on these isolated profiles? Are we talking QA testing, regional validation, maybe client-authorized automation, or internal operations? If actual people rely on the output, your profile setup has to be managed as a core part of the system. Which takes us right into Step 2, defining your profile strategy. Is every task getting its own profile? Are you reusing profiles across sessions? You have to lay down strict rules here to prevent cross-task contamination. You definitely don't want one shared profile leaking cookies or behavioral data into a totally unrelated task.
Moving on to Step 3, set concurrency limits. And please, whatever you do, do not guess your limits. Every single profile eats up memory and CPU. A setup that runs beautifully with 5 profiles might just completely crash your machine if you push it to 20. You have to test the limit, document it, and monitor your resources. Then there's Step 4, define failure categories. Look, when a profile fails, your team needs to know exactly why. You've got to categorize the exact reason for the failure so you aren't treating every single crash as some fresh, mysterious investigation. Because at the end of the day, hardware sets hard limits on how you scale. To put it into perspective, each profile usually demands anywhere from 200 to 500 megabytes of RAM. So if you're running on a standard 16 gigabyte machine, you are safely maxing out at around 10 to 20 parallel profiles. Trying to push past that without keeping a close eye on your resource usage is practically a guaranteed recipe for systemic crashes, and that has absolutely nothing to do with how good your automation script is.
Section 3. Handling failures, categorizing and monitoring the chaos.
To finally stop dealing with generic crashes, we desperately need an exact failure taxonomy. Let's say a profile just won't start. Well, that's often a port conflict, so your quick fix is to verify the API response to ensure no other profile is using that debug port. Or maybe a CAPTCHA gets triggered. You probably have a fingerprint inconsistency, and you can usually fix that by matching your proxy location to the profile's time zone. And if a token is just outright rejected because the profile got flagged as a bot, the fix there is to warm up the profile with some organic browsing first. You really have to categorize the chaos if you want to conquer it.
Continuing with our operational checklist, Step 5 is to monitor workflow outcomes. And I mean really monitor them. Don't just check if a browser window managed to pop open. That brings us to Step 6, which is creating a fallback path. When a profile fails, what actually happens next? Should the system retry, pause, escalate the issue, maybe switch to a different profile, or kick it over to manual review?
You need to define this way before an incident actually happens. Finally, step 7, review authorization governance. You need to document exactly where the workflow is permitted, who approved it, and what boundaries apply. It is crucial that these workflows are only running in owned, client-authorized, or contractually permitted environments. Circling back to monitoring those outcomes for a second, there are a few critical metrics you absolutely need on your dashboard. You want to track your profile's success rate, challenge frequency, and resource usage. But let me be totally clear here. Workflow completion rate is, hands down, the most important metric on this list, period. Because if the task doesn't reliably complete within the expected time, your profile setup just isn't operationally ready. It doesn't matter how smoothly the browser launched initially. Section 4, making automation scalable, common mistakes, and best practices. All right, let's look at how all this translates into actionable, source-backed best practices. First, stick to one profile per task to avoid fingerprint contamination. Next, make sure you rotate proxies per profile so the IP actually matches the fingerprint's location. And, like we touched on a minute ago, warning up profiles on neutral sites builds up that session history, which drastically cuts down on how many CAPTCHAs you'll see. You'll also want to space your requests about 30 to 60 seconds apart to dodge aggressive rate limiting. Clean those cookies out between unrelated runs, and always make sure your WebRTC and date APIs are consistent by matching your time zone to your proxy. Now, flip that around and look at some common operational mistakes. The single biggest trap? Treating browser profiles like they're just disposable, identical windows. Another huge red flag is unintentionally reusing profiles without any strict rules in place. Now, reusing profiles can actually be super useful, but only if it's intentional, fully documented, and tied to a very clear workflow strategy. Also, if you try scaling up parallel sessions without monitoring your CPU and RAM, or if you ignore separating failure types, or if you're only checking if the browser launched instead of if the job finished, well, you're just building a fragile system. Oh, and finally, never, ever ignore clear authorization boundaries. So, the practical takeaway from all of this is actually pretty simple. Browser profile isolation is about making workflows predictable, measurable, and safe to operate. That's the quote to remember. It's not just some clever hack to run a bunch of browser sessions at once. It requires rigorous, disciplined structure to make sure your automation outcomes are actually dependable. So before you go off and try to scale your next automation project, I want you to really ask yourself, which workflow depends on these profiles in your organization right now? How exactly are you going to monitor failure? What happens when the workflow inevitably breaks? And maybe the most important question, who owns the risk when that workflow breaks down due to state leakage or hardware limits? Applying this operational framework directly to your team's infrastructure is absolutely non-negotiable before you start scaling. Which brings us to our final big picture question. Can this workflow scale safely? If you aren't 100% sure, it's time to step back, reevaluate those hardware limits, and put a true profile strategy in place. Seriously, save this checklist before you try scaling your browser automation across multiple profiles. Thanks so much for joining me on this explainer, and I'll catch you on the next one.